So in 1.3 we addressed this problem that we saw in 1.2 that using the real numbers you can't take square roots of negative numbers. In 1.3 we invent a complex number system, a system that will allow us to take square roots of negative numbers. And it starts by defining I, the symbol I, to stand for the square root of negative 1. There's no real number whose square is negative 1, so we just invent this thing and call it I. I is a number whose square is negative 1. I is a complex number, we call it. In general, complex numbers are expressions of the form a plus bi, where a and b are real numbers. So for example, 2 plus 3i is a complex number. 5 plus 4i is a complex number. 7 minus radical 2i. Those are all complex numbers. We call them numbers because you can do arithmetic with them. For example, For example, 2 plus 3i plus 5 plus 4i. Look, if you can add 2 plus 3x and 5 plus 4x, you can do the same thing with x replaced by I. You combine up like terms. That's 7 plus 7i. Subtracting complex numbers is just as easy. Multiplying complex numbers comes down to basically remembering FOIL. Let's say I wanted to multiply 1 plus 4i times 3 minus 2i. So FOIL it out. The first thing is 3. The outside and the inside term gives me some i's. So the inside is 12i, the outside is negative 2i, so altogether that's plus 10i. And the last term gives me minus 4 times 2 is 8, I squared. But I squared is negative 1. So that's 3 plus 10i minus 8 times negative 1. That's 3 plus 8 plus 10i. That's 11 plus 10i. Right? So I say you can do arithmetic with complex numbers because you can multiply two complex numbers and get another complex number, another expression of the form a plus bi. To divide complex numbers involves a little trickery. So I'll try this one. What if I wanted to take 1 plus 4i and divide it, say, by 3 plus 2i. If that's really a complex number, I ought to be able to rewrite that until it looks like a plus bi for some real numbers a and b. Here's the trick. You change the sign of that bit right there and put that in the denominator. You can't just put it in the denominator, though. You can only legitimately multiply the top and bottom by the same thing. When you change the sign of the I coefficient, the new complex number that you get is called the conjugate of the old one. So I'm multiplying the denominator of this fraction by the conjugate of the denominator in top and bottom. Why do that? Well, the top I have to FOIL out. Luckily for me, I just did the top. Example number 3 is exactly this numerator, so I know the top is going to be 11 plus 10i. But what happens at the bottom? Something magical, because look, it's a plus b times a minus b. It must be, I could FOIL it all out, but it must be 3 squared minus the square of 2i. That's 11 plus 10i. That's 9 minus 4i squared. But I squared is negative 1, and I'm running out of room on this piece of paper. This is plus 4. So it's 11 plus 10i divided by 9 plus 4 is 13. Also known as, can I make it fit? 11/13 plus 10/13 I. Made it. See, now that I have complex numbers, I can solve any quadratic equation. I tried to factor this and I failed. So I'm going to try the quadratic formula. It says x equals, let's see, a is 1, the x squared coefficient. B is negative 4, that's the x coefficient. C is the constant term, that's 13. So x is negative b plus or minus square root of b squared minus 4ac all over 2a. So that's 4 plus or minus the square root of, what, 16 minus 52. What is that? 36? No, minus 36. Let me just double check. 16 minus 52 is negative 36, yep. By the way, a lot of students make this mistake. That 4 has a factor of 2. Why can't I cancel a 2 from the 4 and this 2 down here? It's because the top hasn't been factored. The last operation isn't a multiplication. That 4 isn't a factor at the top. Maybe there is a 2 that I can factor out and cancel when I'm done, but not yet. The top hasn't been factored. Anyway, I want to rewrite this radical with the help of I. Because the square root of a product is still a product of the square roots. And this is negative 1 times 36. So I want to take the square root of negative 1 times the square root of 36. Divide by 2. That's 4 plus or minus root 36 is 6. And that's I. So this is 4 plus or minus 6i over 2. Now I'm going to factor out the 2 that I see in the denominator. Because in the top there is a common factor of 2. So the top is 2 times 2 plus or minus 3i. And the 2's can cancel. So the solutions are 2 plus or minus 3i. There are 2 complex solutions to this quadratic equation. Not real numbers, but complex numbers.